Hi all, good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt and I work for Cisco. As you already know that we are working towards this series which is network interview preparation, right? And in every session of this series, we take a question and try to go and learn from that question. Believe me, the intent of this interview preparation series is not to disclose the interview question. The intent is to learn networking fundamentals, right? Or the networking basics. We would like to explain each and every concept, and it doesn't matter whether you are preparing for an interview or whether you are doing a troubleshooting of a network. If you know basics, if you know fundamentals, then it is going to be always with you, right? So having said that, let's talk about a question which is really very, very interesting and very, very important because it comes to everyone's mind whenever they start learning computer networking. It came to my mind, and I have seen many people confused about it. And the question is, why do we need MAC address if we already have IP address, right? An address is an address. Why do we need two? Why can't we just have only one IP address and then call it a day? Why do we need a MAC address? So actually, the concept is really not that difficult at all to understand, but yes, it needs some knowledge of this TCP/IP model, right? And believe me, in my last video, I have explained every nitty-gritties of OSI model and TCP/IP model in great detail. So what we are going to do is we are going to use that knowledge to understand the answer of this question. But to explain this question or to get something out of this question, we need to understand few more things. And what are those things? First thing first, we need to see that actually this question is not just whether we need a MAC address if we already have IP address. This question also says, this question also means, do we need data link layer at all or not? Why I'm saying that, we will be discussing that. So second thing is, if you understand what are the different layer 2 networks we have and what are the different addressing mechanism we have on those layer 2 networks, it is going to be very useful in understanding why do we need MAC address if we already have IP address, right? Then I will prove you with taking an example that why MAC and IP, how MAC and IP goes hand in hand to solve a typical problem of computer networking, right? So as I mentioned in my last videos also, this diagram is going to be with us for this complete series. Right now, as you know, that we are discussing different networks and then basically connecting those networks. So once this series is over, this diagram is going to make a lot of sense to you that yes, you are able to make an internet, you know, you understand networks, you know the host inside network and how to make them communicate, right? It is as simple as that. So let's go. So as you see that 3 minutes have already been gone in just explaining the basics of these questions. Basically, why are we doing this question? So first thing first, let's try to understand why I've included this TCP/IP model again. As you all know that this is a TCP/IP model which is having a layered approach in which we have these 5 layers, right? Application, transport, network, data link, and physical. Now the question arises, at what layer we find MAC addresses? Of course, at data link layer we find MAC addresses, right? And one more thing which I would like to tell you, all these questions, all the questions of this network interview preparation series are in a specific order. They have been designed in a specific order, right? If you follow that order, then basically you can get maximum out of it. Otherwise not, right? So if you haven't seen the last 5 videos, and if you are new to the networking, it is not going to make much sense. This question is not going to make much sense to you. Okay. So just see all those videos, just go in sequence and then come to this video. Okay. So having said that, as you know, MAC is a concept of data link layer and IP address is a concept of network layer. We all know that, right? If I say, do we really need MAC address if I have IP address, right? The question could be that, do we really need data link layer if we have IP layer, right? So we all are pretty confident about this. Yes, absolutely. We need data link layer because we have read in TCP/IP model that data link layer is important, right? But we do not show this kind of confidence when we talk about that, do we need MAC address if we have IP address, right? So believe me, the concepts are similar. But yes, to understand them more closely, to understand them, we need to go a little bit deeper into the history, as well as what are the different layer 2 networks we find, we see uh, in today's network, you can say. Okay, so if you see this board, what we see here is, uh, I have showcased you a network. I have showcased you two networks. One is Ethernet, one is point to point. But to understand these things, we need to talk about a little bit history. So as I mentioned, during 1970s to 19 what we call 90, right? 1970 to 1990, TCP/IP model was under development, right? At 1990, it got completed. Basically, we have a working model where we could have seen that two computers have been talking to each other, right? But around that period, around 1973, there was one guy who was also working on Ethernet network, right? And what is the meaning of Ethernet network? So suppose I would like to explain. So I just wanted to mention that basically in 1973, along with TCP/IP, Ethernet development was also going on, right? So what was the problem, and what problem was these guys able to solve? So suppose an example that there are many guys in a hall, right? Maybe a hall or in a room, right? And you are Mr. Rahul, suppose. You want to go inside this hall, right? And somebody has told you that inside this hall, you will find a person whose name is Mr. Shyam, okay? And you need to deliver this message that, hi, Mr. Shyam, how are you? It is a pretty decent message, right? He's just asking how are you, right? Or maybe some other message which Mr. Rahul wants to deliver to Mr. Shyam, but Rahul hasn't seen Mr. Shyam. He doesn't know Mr. Shyam at all, right? So maybe Mr. Shyam is here, somewhere here, and then we have Mr. X, Mr. Y, and then maybe other people also who are on this inside this hall, right? So generally, what is the approach? How you are going to deliver this message to Mr. Shyam? So what Mr. Rahul has decided, he stood up, right? And specifically say, who is Mr. Shyam, right? Of course, this broadcast, whatever Mr. Rahul is doing, it has gone to Mr. X. It has gone to Mr. It must have been had been reached to Mr. Y, right? And along with that, this broadcast would be reaching to Shyam also, right? But X and Y is not going to respond it. And the reason is because their name is not Shyam. And who is going to respond? Mr. Shyam is going to respond, right? So uh, basically, if there is a hall which is full of people and you want to talk to a specific guy, then basically you need to address them with something. And here exactly what Mr. Rahul is doing. Who is Mr. Shyam, right? So these Ethernet developers knew the fact that if they want these computers to be able to communicate with each other, right, there has to be some mechanism through which they can address each other, and that is where basically concept of MAC came into picture. So every device, means this Mr. Shyam device is also having an address associated, which they call the MAC address. Suppose this address is B colon B colon B, right? And then basically Mr. Rahul address is A colon A colon A. So Mr. Rahul is saying, who is Mr. Shyam? Mr. Shyam is saying, I am Shyam, and here is my address, which is B colon B. So if Rahul wants to send a message, which is say M, to Mr. Sham, what he's specifically doing is he is going to put this address at front of this message, which is B colon B colon B, and send it to this guy, right? Over this wire. It reaches to this guy. This guy is intelligent enough and know where all these MAC addresses are, and then basically it is going to forward it on this address. Sorry, on this corresponding link. So it was simple. Means when these guys, these scientists were developing Ethernet, they came to know that there is a need of addressing, right? And that addressing, basically they came to know that that addressing is known as what we call as MAC address. Okay, so it was pretty simple network. So if I draw a boundary around this network, there is no problem. Means any other person can join this network and can have this MAC address and can start communicating with each other. Please remember, I haven't taken name of IP address at all in this network, right? This is Ethernet network. If they have MAC address, there is no problem in sending this message to others, providing the fact that I know what is the MAC address of other party. If I know the MAC address of other party, I can straight away forward the message to it. And how do I know the MAC address? Basically, there are multiple mechanisms. Maybe I can ask this guy, what is your MAC address? So basically this Rahul can say, who is Mr. Sham? Can you provide your MAC address? And then basically, because Sham is Sham, he's going to reply with the message that, yes, I am Mr. Sham and here is my MAC address, right? So if I know the MAC address in advance, it is very, very simple to just forward this message to Mr. Sham. But now the problem is, suppose we are talking about the computers who are in close proximity, who are pretty close to each other, right? Maybe they are part of the same building, maybe 100 meters or 200 meters apart, and they basically are making a close community here, right? So if we introduce other person also, they can be able to easily communicate. But now consider the fact that we have this Ethernet network. Suppose this Ethernet network number is 1, right? And then there is another Ethernet network which is miles apart from Ethernet 1. Maybe this is Ethernet 2. And now Mr. Sham is not here at all. Mr. Sham is here now. In this network, along with there are many people, right? It is as simple as that. There are many people here. So what is going on? Now Mr. Sham, suppose Mr. Sham is here. Here is Mr. Sham, right? Now what is going to happen? If Mr. Rahul say, who is Mr. Sham here? Right now, Mr. Sham is not here. Okay. Mr. Sham is miles apart from him. And now, basically, this broadcast, whatever Mr. Rahul is sending, if he wants to communicate to this guy, if the restriction is that broadcast cannot go out of this Ethernet network, then basically Mr. Rahul is not able to communicate to this Sham, right? Or maybe we have many such networks. We do not know where exactly Mr. Sham is, right? So the solution of the problem is that we are going into every network or every hall and say, Mr. Sham, are you here in this network? Mr. Sham, are you here in this network? Are you here? Are you here? It means that I'm broadcasting my single message to everywhere, right? And this is not the feasible way of communication, right? Otherwise, if this had been the case, basically there is pretty inefficient network, because one broadcast is traveling to every other network. So Ethernet was able to solve the problem of communication, but inside a closed region, inside a you can say local area, and that is where basically we call that a LAN or local area network, right? So Ethernet means we do not need an IP address at all, right? If there have been only one network and all the computers have been connected to it, but this is not the case. We cannot create a network in which all the computers are connected to each other in the close proximity, because right now we can create a network maybe in India in a particular region, and then basically in US there is a particular region in which we have another network, right? If they are not able to communicate, then we cannot create that internet which we talk about always, right? So Ethernet through MAC address was able to solve the problem, but the problem was solved. The problem of how to make communicate two devices was solved in a particular region, in a local area, right? So we have discussed about a particular type of network at layer 2, which is Ethernet. There were another uh, another networks, like one example of another network is point-to-point network, right? Suppose I have one device and I have another device and I have only one link between them, right? So by the way, I forgot to mention one thing. The networks like Ethernet are also known as multi-access network. And why multi-access network? The reason is because there is only one network here and we have multiple people who are accessing it. And that is why if you have multiple people accessing a single network, you need a addressing scheme. You need an address to identify particular people so that you can send your message towards that particular people or particular person, right? It is as simple as that. But now if we talk about point to point, we know that there is only one link and there is only one guy at the other end. That is why we have a point to point relationship, right? And if we have that, then basically there is no need of addressing. There is no need of MAC addresses here at all, right? So it means that although this technology is the WAN technology because we use point to point across many miles, right? So, but it comes under the category of WAN, wide area networking, and layer two. So at layer two we can find Ethernet. At layer two we can find point-to-point networks also. But point-to-point, those are not multi-access, and that is why we do not need addressing at all, right? We can simply place the message here, and the message will be receiving by the other end because we already know that this is a point-to-point link, and there is only one guy at the end. And if I'm sending a packet towards it, it is going to be reached to that person only because that is the person who is at the other end and there is nobody else, right? So it is as simple as that. I'm not saying that they do not include any header on top of it. They include, but uh, that is not that important. But yes, they include the header, which is the point-to-point header. Now consider the fact that Ethernet network is everywhere, right? They were able to create this Ethernet network. We have one Ethernet network here. This is E1. Suppose this is E2. This is Ethernet number 3, maybe here. It is as simple as that, right? At the same time, as I mentioned, during 1970s to 1990 period, basically TCP/IP model development was also going on, and IP addressing or IP layer development was also going on, right? So we understood the problem in Ethernet network, right? What was the problem? That if Mr. Sham, if Mr. Rahul wants to talk to Mr. Sham here, right? They can easily able to communicate if they find that the person is inside the same Ethernet network, right? But if Mr. Sham is not inside the same Ethernet network, means if he is not in E1 and if he is somewhere here, Mr. Sham is now not here, he is here, then it is posing some challenges to us, right? What was the challenge? Mr. Raul is saying that whether Sham is part of my own network or not. If he is not, then basically I cannot ask, I cannot go into the every Ethernet network because right now you can see there are only 3 networks, but there may be more than 3,000 network or more than 3 lakhs network all over the world. We cannot go in every network and ask that whether Mr. Sham is there or not. So that was the limitation of Ethernet, but it was working pretty fine. If we want to talk between this guy and this guy, who are part of my same network inside the same network, then there is no issue. Ethernet was working like a charm, right? But if these networks are miles apart, then there is no way you can communicate, right? So IP was also looking when TCP/IP model guys were developing IP, they also came to know that sure, just like Ethernet, we also need an addressing. If there is no addressing, then basically there is no point. How I'm going to say that I want to reach if I do not identify this guy, right? So addressing is required, and that was for sure. There was no doubt about it. But IP guys thought it little bit more logically, right? And how they thought it, that they are saying that we do not care about what is there at the final network inside the final network, right? They do not care whether we are running here Ethernet or any other protocol, right? Suppose we are running Ethernet in these three networks. So IP doesn't care about it, that what is going to be there at the data link side, right? They are saying that uh, we have to give an IP address to all these devices. So Mr. Ram also having one IP address. Suppose this complete network is denoted by a network number which is 192.168.10.0/24, right? And according to IP, Mr. Rahul get an IP address from this range, which is 192.168.10.10. Similarly, Mr. Sham, who is here now, who is part of this network, suppose 192.168.30.0/24, and Mr. Sham got the IP address of 192.168.30.10/24, say, right? Similarly, this Ethernet 2, the network, basically which IP address is providing, they are saying that I am giving it an IP address which is slightly more logical. That is the logical address. And what is the logic? We are going to see. So here we are saying that this is 192.168.10. Sorry, 20.0/24. Now, what IP is saying that it is fine that inside the Ethernet address, sorry, inside the Ethernet network, we are pretty fine where we can talk from the MAC. But as you know, MAC is posing a lot of challenges when you talk a miles away. So that is why what I'm going to do is I am going to place different routers here, right? Maybe this is my router number 1, this is router number 2, this is router number 3, and these are connected to these guys, right? It is as simple as that. And now they are also connected with each other. Okay. What is the meaning of the connection? The meaning of the connection is that all these routers knows who is connected to what. Mean which network, which Ethernet network is connected to what. For example, on this R1, I can say that 192.168.10.10 network is directly connected. Of course, it is directly connected, right? Like this. I can also say that network 192.168.30.0/24 is connected to R3. And if I want to reach to this network, I have to go to R3 first. And then it is the responsibility of R3 to send it towards the E3. For example, now suppose Mr. Rahul wants to communicate to this guy, Mr. Sham, right? So how it is going to happen? It is going to create this IP packet whose source IP address is going to be very simple, 192.168.10.10, right? Destination address is going to be 192.168.30.10, right? This is going to be reaching here at this router, because this router from you want to talk to from this router to this router, right? Or the host, whatever the connected to this switch. Now, what is going to happen? First thing first, this host is going to see that whether the destination IP address is on my own local network or not, and they can easily calculate how. You can also calculate if you see the first video of this series, which is on subnetting, right? As you can see that 192.168.30.10 is not attached to me, right? It is not on my network because this host is part of a network which is 192.168.30.0. So this guy straight away know that there is no point of broadcasting that message that Mr. Sham, are you there? Tell me your MAC address, because Mr. Sham is not there at all. And how these guys came to know? These guys came to know from the IP address itself, right? Mr. Ram just see the IP address of Mr. Sham, Mr. Rahul just see the IP address of Mr. Sham, that 192.168.30.0.10 is not part of my network at all. So it is not not worth to just see and ask that whether you are part of my network or not, because it is not, right? It is mentioned, and that is the logic of IP address. By seeing the IP address, Mr. Rahul came to know that Mr. Sham is not in my network. What is the case if Mr. Sham was here? If Mr. Sham was here, then his IP address should be 192.168.10 dot something, right? But it is not in the network, so Mr. Rahul came to know that Sham is not part of my network. There is no benefit of sending him as a broadcast that you are there. If you are there, send me your MAC address, right? So there is no point. So what basically IP is saying that if your destination, if the destination to which you want to communicate, it's not part of your local network, it's not part of it's not a part of your Ethernet network, then send it to me, send it to the nearest router, and the nearest router is called as a gateway, right? Send it to me because I may know that where is this guy, right? So this IP packet from Rahul reaches to this guy, which is your R1. It is as simple as that. R1 sees its routing table. It is very interesting fact that how come R1 know about a route which is connected to R3 or the network which is connected to R3. It is very simple, and that is where routing protocols come into picture, which we are going to routing protocol comes into picture, which we are going to see in upcoming videos. So do not worry about it. But through routing protocol, we know that which router is connected to which Ethernet networks, right? So this packet, this IP packet reaches to R1, right? R1 sees inside its routing table and sees that 192.168.30.0/20 for network. There is an entry, and if router 1 wants to send packet to this network, he has to send packet to first to R2, right? So this yellow packet first reaches to R1. R1 sees the routing table. It comes to know that if he wants to reach there, he wants to send to this packet to R2, and R2 is right here. Sorry, not R2. This is actually R3, right here. So basically, R1 is going to send it towards R3. It is as simple as that. Now R3 sees, okay, this guy is connected to me because I know that this interface, whatever I have, is configured with this 192.168.30 dot something, right? So I know this network is directly connected to me. But here is the problem. Right now, if I send an IP packet directly, who is having the destination address of 30.10, suppose this is your IP packet. I haven't written the source IP address, that is fine. You can identify that this is an IP packet which wants to reach to 30.10. R3, if it sends just like 30.10, it is not going to be work, right? And the reason is it is not going to work. And the reason is this network doesn't understand IP address at all, right? This network understand what? MAC address. So R3 will assign a MAC address. Whatever the MAC address associated with this may be A colon A. He is going to put A colon here, and then basically it is going to be delivered here. So basically, from networks to networks, right? It is the responsibility of IP to see the packet destination address and send it towards the final router. At final router, basically, and you can see that this packet is not going to go to R2 because R2, there is no way this packet is going because R2 doesn't have any reachability to this network, right? So it is going to R1 and then basically it is going directly to R3. It is as simple as that because R3 has the reachability to this network, right? So IP is making this process a logical process, a more efficient process, right? It sees the destination MAC address, sees that, okay, the destination MAC address is 192.168.30.10. If I want to send it, I need to send it to R3 first. Then R3 says, okay, it is my directly connected route. I will be forwarding it, right? No problem at all. But at the final LAN, at the final local area network, which is your Ethernet 3, where Mr. Sham is there, right? This is what type of network is this? This is Ethernet network. It doesn't understand IP address, right? Although I have assigned an IP address to this guy, but if I want to send this IP address to this network is meant to work on MAC addresses, right? So we need to put some MAC address along with that, and that is why we need MAC addresses, right? along with it, because Ethernet doesn't understand that. And it was developed along with IPs around 1973, right? So along with that, if I say that what are the other different technologies at the layer 2 network, as I mentioned, we have Ethernet, we have point to point, we have certain other WAN technologies like frame relay, like ATM. Those technologies were there also, which are part of the uh, uh, my layer 2 technologies, right? Where the addressing scheme is different. So Ethernet addressing scheme is MAC, right? At point to point, we do not need addresses, right, at all. Basically, the layer 2 addresses, because we know what is at the other end side, right? No problem, because there is only one guy. So if I need to send a packet, I am just going to put the packet onto the wire, and because I know there is only one guy, it has to reach there. It is as simple as that, right? So on the frame relay, there is a different kind of mechanism, addressing a scheme which we call as data link connection identifiers, right? But we do not want to go deeper into that because those technology are not used now, right? But it doesn't mean that only Ethernet was there. There were so many technologies at layer 2 level, right? Or your data link, frame relay, ATM, point to point, Ethernet, right? But the most predominant one is Ethernet. And that is why you see Ethernet, and that is why you see MAC. But there were more technologies than Ethernet, right? And there were many addressing schemes. Like on Ethernet, you use MAC addresses. On frame relay, you use DELCs, right? ATMs, you use something else. So there are many technologies with many addressing schemes, right? But I'm not saying that Ethernet is superior or frame relay is inferior. As we have proved you, it's not always the case that the superior technology is going to win. For example, if you consider OSI and TCP/IP model, OSI model no doubt has a lot of specification protocol which are more superior as compared to TCP/IP. But who won? TCP/IP. The internet is working on TCP/IP, right? And OSI model is a reference model which we use. So it is not I'm not talking about which one is superior or which one is inferior. The person who was developing it sees a value in different addressing scheme. That is why it is using different addressing scheme. But IP does not care about it. IP layer just say, I can forward the packet, right? Which are to the network which are geographically apart using the routers in between, right? I can send one packet from one router to other router to make sure that it is going to reach at the destination, right? When it reaches the destination router and the network is directly connected to it, then basically I do not care what data link is attached to it. Maybe it's a point-to-point link, maybe it's a frame relay, maybe it's an Ethernet, right? It is the addressing mechanism of those layer 2 technology which is going to help me sending my IP packet to that guy. But yes, I will assign an IP packet to each and every host, right? And those IP addresses are logical because routers which are in middle going to understand it, and if they understand it, they are going to make sure that my IP packet reaches to the final router, where basically I am going to use the different layer 2 addressing schemes like frame relay, like Ethernet. I'm going to utilize those Ethernet or frame relay to send my packet over them. And to explain that topic, I am going to include one more board which I have already included in the last video, right? But this board is absolutely fantastic to understand why do we need MAC and IP both, right? So consider we have a server here, and the IP address of this server is 5.5.5.5. As simple as that, no problems, right? It is connected to this router, and maybe this router name is R2, this router name is R1, right? This router has a routing table. And of course, you understand that all the routers build routing table on the basis of maybe routing protocol or on the basis of whatever the connected routes they have, right? So they have this routing table. Inside this routing table, I can see there are two routes. One is to reach 192.168.1.0. It is a connected route, which is right here, right? And the next hop is basically connected because this is a connected route, and the interface over it which it is reachable is FA0/1. The second thing is basically 5.5.5.0/24, which is reachable via this router, and this router address is 10.10.10.1. It is as simple as that, right? Over this interface, which is your FA 0/2, this one, right? So first, let's talk about what is going to happen. What is going to happen when the router has a packet which has the destination IP address 5.5.5.5, right? And this is the IP packet. This packet is on router R2, which is router R1, which is this one, and router R2, which is this one. It is as simple as that. When this packet reaches here on this router R1, it is going to see its routing table, and it is going to see that to reach network 5.5.5.0, and by the way, IP address 5.5.5.5 is part of network 5.5.5.0/24. And why? You all know, because you know the subnetting. And if you don't, then again I'm saying all these videos are interrelated. All these questions are interrelated. So first thing first, go see first video, then second, then third, then fourth, and then fifth, and then come to this one, which is the sixth one. Okay. So the packet wants to go to 5.5.5.5. It sees here is the routing table, which is 5.5.5.0. And to reach to this network, we need to forward this packet to 10.10.10.1 over this interface FA0/2. And now here basically router sees that actually there are different kind of links associated with me. One link is point to point. The other link is Ethernet, right? This link is Ethernet, as I mentioned. So this point-to-point link, this IP address, this IP packet can be go as it is, right? Of course, there is a header of point-to-point protocol, maybe PPP. Let's write this way, PPP, right? So this packet can go here, and then, but router is smart enough to see that there are two links attached to me. One is towards Ethernet, the other one is towards point-to-point. But this packet is going towards point-to-point link because the address 5.5.5 is reachable over point-to-point and not over Ethernet. It means that we do not need MAC address here at all, right? Because over the point-to-point link, we know that only the one guy is there. So it is not a multi-access network, right? What is multi-access network? This one is multi-access network, and that is why we need addresses on it, right? But here, basically, I know that over this link, only one guy is connected, so we do not need it. So whatever the point-to-point header is there, I will attach it. And basically, there is a trailer also for the checksum calculation and all. And this packet is going to be over this link and reaches to R2. R2 is directly connected, and it is going to be forwarded like this. It is as simple as that. But router is intelligent enough to know that basically we have two data links. One data link is point to point, the other is Ethernet, but my routing table says that this packet is going to go over the point to point, and I need to create a point to point header, which I is going to paste at the front of the IP packet, and then I'm going to forward it over my point-to-point link. It is as simple as that. But now consider a case, right? Now let's see. Here I have proven that we do not need MAC address over the point-to-point. But now what happens? Suppose there is an IP packet who wants to go to 192.168.1.10 network, and here basically this IP address is here. So every device on TCP IP model require an IP address, right? So IP protocol developer has made sure that we are going to have this IP address to every device, which is uniquely identifying this device. So 192.168.1.10 is the IP address, right? Maybe /24, the subnet mask is here. And because this is a Ethernet network, right? Because this is a switch, and by the way, switch works at the layer 2. It only understands the MAC address and nothing else. So this one was my Ethernet address, and on what addresses Ethernet works? Simply the MAC address. And suppose the MAC address is of this guy is A:/A:/A. This guy is suppose B colon B colon B, and maybe the IP address maybe 1.20 or maybe 1. Whatever, right? From this network only. So this complete network, as I mentioned, this complete network is going to be my one Ethernet network, which is attached to this router, which I was mentioning as R1, right? So this packet came on this router R1. Again, router is going to check its routing table. There is a match, right? 192.168.1.10 is part of this network, which is 192.168.1.0/24, and it is connected directly to this router over the interface FA0/1, right? So what I need to do, I can send this IP packet to this guy over FA0/1, right? So this IP packet can go over here. But if I place this IP packet just like this, right? This was my IP packet. What is written into that? The destination MAC address, which is 192.168.1.10. It is as simple as that, right? But the problem is when this packet reaches here, it reaches to this switch. Switch does not understand IP address at all, because when this Ethernet was developed, right? Ethernet developer guys didn't know about IP addressing at all, right? They developed this Ethernet complete network on the basis of MAC address, right? And IP says that is perfectly fine, no problems at all. I want to reach to 192.168.1.10. Just tell me, Mr. Ethernet, what is the your addressing scheme corresponding to that, right? So that is where basically this router asks in this network, it broadcasts in this network, right? That who has 192.168.1.10, right? And what is the meaning of who has 192.168.1.10? It is asking that because this is a Ethernet link, right? I am pretty sure that if I send an IP packet, it is not going to be delivered to the destination 1.10, because whatever the device is here is not able to understand, right? The IP address, and that is why basically it is going to say that that who has 192.168.1.10, tell me your MAC address, right? And that is where basically your ARP request is, and we have understood it in great detail in our initial sections, right? So no problems with respect to it. Now this guy is going to reply to this router on to this ARP query that I am having A colon A colon A as a MAC address, right? So router know now that basically this packet is for 192.168.1.10, because I cannot send the IP packet directly on this media, right? So till network layer, my responsibility is over, right? Network layer, I have an IP address. Now I will send it to the data link layer to send it across, right? So data link layer is going, what is going to do is whatever the IP address it was receiving from top, it is going to put the MAC address on top of it, right? And what is the MAC address? MAC address is going to be A colon A colon A. So router will place this A colon A colon A, and then basically it is going to reach at this switch. Switch will see, okay, A colon A is attached to this guy, and he will be delivering this packet to this one, right? Once it is reached, A colon is removed, and then basically we are going to have this IP packet, which is delivered to above layers. So it is as simple as that. But now the problem is, actually now there is no problem, but you can understand that the router can ask in a particular medium, right? Can ask in a particular network that what is the addressing scheme at that medium. For example, router is intelligent enough to know that FA0/1 is my Ethernet link, and the addressing mechanism, if I want to send the packet to Ethernet, then basically I know I should involve MAC address. So I am doing an ARP, I'm receiving an ARP reply, and then I will place this A colon A at the front of this IP address, and then I can forward this packet over this link, right? So IP layer was never built to take care of data link portion also, because at data link you can have multiple networks, right? This is a data link which is point to point. This is a data link which is your Ethernet. Maybe there could be another data link which is your frame relay. So it is not the responsibility of IP to tackle with all different types of data link, which is frame relay, point to point, or basically we have this one, Ethernet, right? So what IP does that it has a IP address or IP packet which is having the source IP and destination IP. By the way, I write only destination IP. So try to understand this IP header contains a lot of things, but I have mentioned only the destination IP, right? So it only have the source IP and destination IP and then forward this entire complete packet to data link layer and leave it to them that it is now your responsibility to see that basically where you need to send it, whether the frame relay over the PPP over the Ethernet. If you are sending it over the Ethernet, then basically it is the responsibility of data link layer now to put a MAC layer. If it is sending on the point to point, then basically it is no addressing scheme is required. If you are sending it over the frame relay, then maybe the frame relay addressing scheme is required, which is data link connection identifier, right? So very, very simple thing, but try to understand this concept that if we have network layer, if we have data link layer, the network layer responsibility, although we have IP address configured at all the devices which uniquely identify the device, the responsibility of the network layer is to just send the IP packet from one host to the network, to the final network or the final router, right? This packet is going to reach, and how come this packet is going to reach? Based on the IP address, because those IP addresses are logical, and the routers which are the intermediary between these networks, right? They see the packet, they see the what is the destination IP address, they forward it, and the packet reaches to the final router. And if it reaches to the final router, it is as simple as that. It doesn't matter what are the various data links, whether it's a point-to-point, Ethernet, or something else. If it is an Ethernet, then basically the router say, okay, it's a data link responsibility. Now IP responsibility is done. No problem. I will send my packet to data link. Data link layer will see, okay, it needs to send it to Ethernet, and that is why they are going to include MAC addresses, right? So it is pretty simple to understand, by the way, guys, if you understand the whole soul structure, how these layers are built, right? What is the responsibility of network layer? What is the responsibility of data link layer? If you understand that the at layer 2 there is not only one network which is your Ethernet, and this is the problem with current engineers, because they have seen most of the times only Ethernet. They see that there is a MAC address and there is an IP address, and why do we need both of them? Just try to understand. At a router level, we have different data links, right? And that is why we need another layer, data link layer, which specifies if you need to send a packet over point to point, if you need to send a packet over data over Ethernet or frame relay, right? So very simple. Uh, I think I was whatever I needed to explain to this board. I am done with that, right? So last thing which I would like to cover it again. If you see that basically we have these two layers, we have network layer and we have data link layer. So at data link layer, we can have multiple technologies, right? At data link layer, we can have Ethernet, we can have frame relay, we can have point to point, and many more. Maybe HDLC also, which is previous to point, right? At network layer, we have IP, right? IP is logical one. It means that when we have a lot of networks, like if we have a lot of networks, and if we have a host here, if we want to communicate inside a particular host, then basically over the Ethernet network, we can communicate, no problems at all. But if you want to send a packet from this LAN network to this LAN network, which is miles apart, and basically which is connected through various networks or routers, then basically we need the help of IP to actually forward it to first thing first to the final router, and this router has to see. I'm repeating this once again so that you are absolutely sure, right? When the packet reaches at the final router, it is the final router responsibility to transfer it to the data link layer, and then data link layer decides that whether it needs to send to the frame relay or point to point. If it is attached to Ethernet, then basically it is going to attach a MAC address along on top of the IP address and send it to the final destination. It is as simple as that. So hope you have enjoyed this video, because this is the question I am seeing on a lot of places on internet, that People says IP address is logical, IP and the MAC address is Barnin address. This is a physical address. Guys, all these things are correct, right? No problems at all with the explanation, but try to understand why do we need at the first place, right? Because Ethernet development was already going on in 1973. They came across the fact that yes, they do need a addressing scheme. They came up across with MAC. IP layer doesn't care about what basically data link you are running, Ethernet or something else. They say that I am pretty logical. I can forward it to the last mile, and then basically I can give it to data link to deliver to the final host. And then basically when it delivers me, I'll remove this header. I will remove the MAC address and going it back to my IP layer. It is as simple as that. Hope you have enjoyed this video, and see you in the next video where we are going to discuss our first troubleshooting tool, which is traceroute. Believe me, traceroute, I believe every network engineers use, right? But if we understand the things, how basically it is going, how it is working, what are the various things which are behind the scene of traceroute. If we understand that, then basically it is going to help us more in our troubleshooting, right? So we are going to discuss that in upcoming video. Till then, have a nice day. See you in my next video. Bye bye for now. Have a nice day.